myself Dr. PJD Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss regarding OOP methodology and principles. The object-oriented principles and methodology topic outcome is mapped to the course outcome of CO1, which is identify the appropriate process models, approaches and techniques to manage a given software development process. In this video, I will discuss regarding what is object-oriented software engineering and what are the principles and guidelines for object-oriented design and what are various methodologies available in the object-oriented design. Object-oriented software engineering can be referred as a software design concept that is used in the object-oriented programming for the purpose of designing software modules. So, the conceptual framework of object-oriented systems is based upon the object model. So, the object-oriented programming principles are used for the construction of the software, and the programming and designing of the modules are based on object-oriented programming principles. So, object-oriented programming is a software engineering methodology that organizes software design around objects, data, instead of logic and functions. As in procedural language, is majorly concentrating on logics and function, but in case of object-oriented programming principles, the major focus is around what are the objects and the data upon which these objects operates. Evaluation of object-oriented paradigm. So, in the 1980s, Grady Booch published a paper. Title is Object-Oriented Design that mainly presents a design for the programming language, ADA. By using this ADA programming language, how object-oriented design must be performed. In that ensuing editions, he extended his ideas to a complete object-oriented design method. After that, a decade, 1990, COD incorporated behavioral ideas to object-oriented methods. So, the other significant innovations were object modeling techniques by James Ramberg and object-oriented software engineering by Ivar Jacobson. So, majorly for the object-oriented design, the Grady Booch, the James Ramberg and Ivar Jacobson works are served as the foundation. In the object-oriented and design and analysis, the object model visualizes the elements in a software application in terms of objects. So, the concepts of objects and classes are intrinsically linked with each other from the foundation of object-oriented paradigm. So, object-oriented analysis and design is a software engineering methodology that uses object-oriented principles and in order to implement the software system. So, with the analysis and design, the blueprint of the designed system must be constructed with variety of diagrams which will pictorially represent the basic functionalities for the development or implemented software. Generally, the object-oriented software engineering practice can focus on object-oriented modeling, use cases, design patterns. These are the basic components for the design. So, in the object-oriented modeling, involves using of visual diagrams to represent the different objects in a software system and their relationships to each other. The use cases serves as the basic element which is generally used to represent the features of the software, and in the use case diagram how various users or the stakeholders can interact with the designed system. So this involves describing different ways in which users will interact with a software system. Design patterns involves using reusable solutions to a common problems in the software design. The advantages of this methodology is it helps in faster development of the software, easy to maintain. Suppose a module develops an error, then the programmer can fix that particular module while the other part of the software is still up and running. So it prevents the error propagation in the next modules. It supports relatively hassle-free upgrades. So it enables reuse of components, designs and functions with the help of design patterns. It reduces development risk, particularly in integration of complex systems. The object-oriented methodology, the basic principles that can be involved are the object, class, the messages, abstraction, encapsulation, inheritance, and polymorphism. The objects are used as a real-world elements in an object-oriented environment that may have a physical or a conceptual existence. Identity that distinguish it from other objects in the system. State that determines the characteristic properties of an object as well as the values for the properties that object hold. Behavior represents externally visible activities performed by an object in terms of changes in its state. So, majorly, objects can represent the identity, the state and the behavior. Objects can be modeled according to the need of the development. The class is a representation of collection of objects having the same characteristic or properties that exhibit common behavior. So, it gives a blueprint or a description of object that can be created from it. Creation of an object as a member of class is called the instantiation. And a set of attributes for the objects that are to be instantiated from the class. A set of operations that portray the behavior of the objects of the class. So, class can also be having three compartments while representing the UML diagrams. The class name or identity, the data on which the class or object must be instantiated, and the operations or methods which will provide the behavior. Encapsulation is another principle in that it is the process of binding both attributes and methods together within a class. And through encapsulation, the internal details of the class can be hidden from the outside. It permits the elements of the class to be accessed from outside only through the interface provided by the class. So, in the UML, you can represent the class with rectangular with three compartments generally. Here, we must specify the class name. Here, the data types, the data on which this class operates. Next, the methods or operations. So, in a single capsule, we are integrating the data and methods. That property is called encapsulation. And here we can also use the access specifiers to represent the access methods, and the members of the class can be visible or accessed inside or outside the class. So here the visibility specifier must be represented. Hash is used in the protected environment. Like that, the symbols that can be used in the UML language in order to specify the access specifiers. The advantage of this encapsulation keeps data safe and prevents unauthorized access or modification. It allows controlled access to data through methods. You can also change the internal working of an object without affecting the code that uses it. Encapsulation makes code easier to understand and maintain because the user only needs to focus on what the class does, not how it can be done. The disadvantages are it can add extra layer to your code, making it a bit more complex. Encapsulation can sometimes make your code a bit slower because of extra control it imposes. Next principle is message passing. So here in any application requires a number of objects interacting in a harmonious manner. So the communication between objects can be only possible with the message passing. Objects in a system may communicate with each other using the message passing. Message passing between two objects is generally unidirectional. Message passing enables all interactions between the objects. So essentially it involves invoking the class methods. For example, consider two classes. Here this is the student class and this is the course class. So these two classes can be related and communicated with the help of message passing. How the message can be denoted is with the arrow in which direction the message is passing, upon which the message sent. Okay. Like that it must be represented in the UML diagrams. So the direction of flow, what message must be exchanged between the objects in the communication. So student, register the course. Next is inheritance. Inheritance is the mechanism that permits new classes can be created from the existing classes by extending, refining its capabilities. The existing classes are called the base class, parent class or the super class. And the new classes are called derived class, child class or subclass. The subclass can inherit or derive the attributes and methods of superclasses provided that the superclass allows so. Besides, the subclass may add its own attributes and methods and may modify any of the superclass method. So types of inheritance are single inheritance, hybrid inheritance, multi-level inheritance, hierarchical inheritance, multiple inheritance. The single inheritance is a subclass derives from a single superclass. For example, consider here student is the class, student having scholarship is one more class. From the student class, this subclass student having scholarship is derived. So, with a single superclass, single derived class must be exist. Then that type of inheritance is called single inheritance. Next is multiple inheritance. A subclass derives from more than one superclass. So, consider an example. Wheel is a class, rubber is a one more superclass. From these two superclasses, one derived class must has to be exist, that is the type. This type of inheritance is called multiple inheritance. This tier subclass has to be derived from multiple superclasses of wheel and tractor. Multi-level inheritance. A subclass is derived from superclass, which in turn is derived from another class, and so on. So here in the multi-level, the superclass, consider an example of animal superclass from which a subclass is derived, that is the mammal class. So here this is the single inheritance, but from this derived class, one more derived class or the subclass exists, that is the human. So this type of inheritance is called multi-level inheritance. Hierarchical inheritance. A class has a number of subclasses, each of which may have subsequent subclasses continuing for number of levels so as to form the tree structure, that is called hierarchical inheritance. Consider an example vehicle. From the superclass, three derived classes must exist: land, water and air. From these derived classes, one more level of subclasses are derived: from the land, car and bus; from the water, ship and boat; from the air, aeroplane and helicopter. This forms a tree structure. So this type of inheritance is called hierarchical inheritance. Next type is hybrid inheritance. It is a combination of multiple and multi-level inheritance so as to form a lattice structure. Consider an example person. This is the base class from which student and employee are the derived classes, from which the next level student intern is derived. So here this is the single inheritance until this next multiple inheritance. So by the combination of this multiple and multi-level, from the derived class one more class is derived, then it is called as hybrid inheritance. Next principle is polymorphism. Polymorphism is originally a Greek word that means that ability to take multiple forms. So in object-oriented paradigm, polymorphism implies using operations in different ways depending upon the instance they are operating upon. So it allows objects with different internal structure to have a common external interface. Polymorphism is particularly effective while implementing the inheritance. So consider here this steering, we are using n number of vehicles. The single one we can use in many forms. Abstraction is one more principle of book. It is about using the objects and classing without worrying about how they work internally. Only the abstract or the summary details must be provided, but without giving the additional details how to implement the objects. So what they can do and how to use them, hiding of these details. So just like using the TV remote without knowing how an electrical engineer can make it, that we cannot know, but how to operate it we can know and we can use it. Advantages are abstraction makes things simpler, so it helps focusing on what important, ignore what's not. And it reuses the same template for different things, so saving time, making our work more efficient. When something goes wrong, need an update, we can fix just part that broken without messing up everything else. So abstraction helps us grow our projects without making them messy. The disadvantages are too much abstraction can make things more harder to understand. Abstraction can add extra work and code that might slow down our program a little bit. Using abstraction tools can be tricky for the beginners. So, in the object-oriented methodologies, variety of software engineers can work. Grady Booch methodology of object-oriented software engineering is, it uses the basic principles of strategies, techniques of encapsulation, essential for crafting resilient and adaptable software systems. It emphasizes the modularity, encapsulation, abstraction to create flexible and maintainable software solutions. The key elements of Grady Booch approach is object modeling, class diagrams, dynamic modeling. In the object modeling, identifying the key entities or objects within the system along with their attributes, behavior and relationships. The class diagram visually represent the static structure of the system, including class, their attributes, methods and associations. The dynamic modeling, analyzing modeling the dynamic behavior of the system during runtime, including interactions between objects, state transitions and sequence diagrams. Not only this, the architectural design, object-oriented design principles are concentrated by Grady Booch. In the architectural design, the overall architecture of the system, including organization of classes, modules, components, as well as defining interfaces and dependencies, to represent the architecture more scalable, maintainable, and adaptable to changes. The object-oriented design principles such as encapsulation, inheritance, polymorphism, abstraction ensure modular and reusable code. Further, the Grady Booch concentrate on iterative and increment development, documentation, tool support. So, in the iterative and increment development, software system is evaluated through multiple cycles of analysis, design, implementation and testing. This allows for feedback-driven refinement and continuous improvement. The documentation serves as reference for the developers, testers and stakeholders throughout the project lifecycle. It is major means of communication between variety of stakeholders of the project. The tool support, leveraging appropriate tools and technologies to facilitate the modeling, design, implementation and testing activities. So, the GRASP principle are the other approach of object-oriented software design, which stands for General Responsibility Assignment Software Patterns, includes several principles that guide the allocation of responsibilities in object-oriented design. In object-oriented analysis and design, GRASP principles hold significant importance to provide the basic framework for designing system with clarity, flexibility and maintainability. The GRASP principles are creator, information expert, low coupling, high cohesion, controller, pure fabrication, indirection, polymorphism. The creator assigns the responsibility of creating instances of a class so that more knowledge about when and how to create them can be used by the creator. The information expert assigns responsibility to the class that has the necessary information to fulfill it, promoting high cohesion and minimizing the coupling between the classes. Low coupling aims classes to have minimal dependencies on each other, facilitating easier maintenance, flexibility in the system. So the functional dependencies are greatly minimized with low coupling. High cohesion ensure that responsibilities within the class are closely related and focused, ensuring reusability, maintainability, etc. Controller assign responsibility of handling system events, coordinating activities to a controller class, promoting centralized control. Pure fabrication introduces new classes to fulfill responsibilities without violating cohesion and coupling principle. Indirection use abstractions to decouple classes and promote flexibility in design. Polymorphism utilize inheritance and interfaces to enable multiple implementations of behaviors allowed for the flexible and extensible systems. All these are the Graph's principles. Next advancement in the object-oriented analysis and design is unified process. So it is an object-oriented analysis and design is flexible and iterative approach to develop the software. It focuses on creating working software increments, collaborating with team members and adapting to changes. It is based on the unified modeling language and is characterized by its use of use cases to drive the development. It focuses on architectural centric, encompasses risk management and incremental delivery. So the importance of unified processes. Complex software projects are made more manageable by unified process. It breaks them into smaller and iterative chunks. Clear guidelines and workflows from unified process to boost the implementation and communication. It ensures stakeholders' collaboration and continuous feedback is emphasized by unified process. High quality software meeting requirements are the results. The unified process generally can have the phased development which encompasses inception, elaboration, construction and transition. These four phases are closely related with the major framework activities. Those are the communication, planning, modeling, construction and deployment. So, these are closely related. The communication and planning, part of the planning are carried out in the inspection. Planning and part of the modeling is carried out in the elaboration. The construction is purely on testing and development of the software. After that, it is delivered to the in the deployment to the client side. That is the transition. Where the client side, the software is put into operation is the production. The advantages of unified process is offering thorough documentation, enhancing risk management practices, giving regular feedback to stakeholders, reducing total project time, determining working element early in the process. The disadvantages are complexity of process. The amount of documentation required for unified process can be time consuming and expensive. Challenging of using it for projects with multiple development streams is critical. So in this video, I discussed regarding what is the object-oriented software methodology, the basic principles that are used in object-oriented programming, and what are the other advancements in the object-oriented software engineering methodologies like Grady-Grass methodology and unified process. The references used in this video are this. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.